Splines allow game entities to follow predetermined paths and allow them to simulate natural motion. Splines are comprised of multiple connected curves, the most common type of which is the cubic Bezier. Cubic Bezier curves use 4 control points to determine their shape. Bezier curves were created by French engineer Pierre Bezier, who used them to design curves for the bodywork of Renault cars. Bezier curves use Bernstein's polynomial equations to define a group of functions which all use a single parameter. They are as follows. As you can see, the functions have an inverse relationship with one another, which is even more clear when we look at the visual representation of the output of these functions. The Bernstein functions are a special type of weighted sum called a convex combination. Any curve created by the control points will reside within the convex hull of the polygon, which has the control points as its vertices. The sum of the Bernstein functions is always equal to 1. The curve always starts at the first control point and ends at the last. A Bezier curve will only form a line if all the control points are collinear. Circles, ellipses, and hyperbolas cannot be exactly described by Bezier curves, but they can be approximated by them to a high degree of accuracy. A quadratic Bezier, which is one with 3 control points, can be an exact segment of a parabola because parabolas are defined by a quadratic equation. In this snippet, you can see that when the control points for adjoining curves create a line, the directional change is smooth. When the lines are the same length, the change of speed is also smooth. The further control points are between each other, the faster the entity will move between them. We create a class to represent a curve. We encapsulate an array of 4 control points and an array of 4 bounding spheres to test for collision between the points and the mouse cursor in the level editor. The speed coefficient variable multiplies the speed of all entities that travel along the splines. The default gap variable determines the distance between the control points when a curve is instanced. We have 2 initialize functions. The first sets the control points via an array of points which is passed through, the second one through 4 individual points that are passed through. SetPoint sets the position of a control point. GetPoint returns the position of a control point. SetBoundingSpheres initializes the bounding spheres for each control point. The curveFollower class inherits from the Entity class. The Entity class is used for in-game objects that have models, transformations, and bounding volumes. The curves array will dynamically allocate curves up to a maximum amount. The velocity variable is used to calculate the velocity of an entity that is moving along the spline. The number of curves variable keeps track of how many curves the entity is using for the spline. Curve index and point index refer to the curve and control point that were last selected in the level editor. Current curve represents the curve that the entity is currently following. Delta curve represents how far the entity has moved along a curve, and it ranges from 0 to 1. The initialize function allocates the memory for the curves and positions the control points relative to the location of the model. Each point of the curve is separated by the default gap size along the x-axis. The bounding spheres are then set for each control point. The followPath function updates the x and y positions of the entity using the Bernstein functions. I do not update the z-axis because my game is 2.5D. We then increment the delta and see whether it is above 1. If it is, we move on to the next curve or reset it back to the first if we have just processed the final one. The rotate to direction function orients the entity towards the direction of its velocity. We use the local z and y axes of the entity to construct a plane. We test whether the angular distance between the current direction of the entity and the target direction is more than the speed of rotation per frame. If it is, we update the orientation around the local y-axis. The distance variable tells us whether the target direction is in the positive or negative half space of the plane, so we know whether to invert the rotation speed. The update function calls the follow path, rotate to direction, and update current animation functions. The isPointInControlPoint function determines whether the mouse cursor has collided with one of the control points when the left mouse button was pressed. If so, it sets the corresponding curve and control point as active and resets the current curve so that the entity starts from the beginning when the Continue Game button is pressed. The isPointInVolume function overrides the entity base class function so that the control points are tested first for mouse cursor collision. If there is no collision with the control points, it checks for collision with the bounding volume of the entity. The setPosition function also overrides an entity base class function. If the first control point of the first curve is selected, it moves the entity to its position. Otherwise, it just moves the control point. If no curves have been allocated, it moves the entity as usual. The updateEnditing function adds points and lines to the render manager so it can render the curves and control points for the level editor. The reset function resets the entity's position to the first control point. SetNumberOfCurves is used to increment or decrement the number of curves in the level editor.